Hello everyone, welcome back to my YouTube channel. So now we are going to solve question number 1 of weekly contest 461 Trionic Array 1. Okay, so let's read the problem statement. You are given an integer array nums of length n. An array is trionic if there exist indices 0, okay, 0, then p, okay, and p should be greater than 0, okay, then q and q should be greater than p, okay, and q should be less than n minus 1, okay, n minus 1 like this, okay. An array is trionic if there exist indices 0, p, q, n minus 1 such that nums 0 to p is strictly increasing, okay. 0 to p, all the elements should be strictly increasing, okay, not same, okay. So here let's suppose 20 and again 20, here again 20, that is not strictly increasing, okay. Strictly increasing means after 20 30 will come, okay, after 30 something greater than 30 will come, okay, that's the meaning of strictly increasing, okay. And then p to q strictly decreasing, so like this, strictly decreasing, like 20, 19, 18, 17, 16, like this, okay. Then q to n minus 1 again strictly increasing, all right, strictly increasing, all right. So we have to return true if nums is trionic, otherwise we have to return false, okay. Constants, if you see, n is from 3 to 100 and nums of I value from minus 1000 to 1000, okay. But here if you see this, we need 0, p, q, n minus 1 like this. So there will be at least, there should be at least 4 elements in the nums, okay. If there are less than 4 elements in nums, we can simply return false, okay. Then we can't do this, right? 0 to p, then p to q, and q to n minus 1. So there should be at least 4 elements in the nums array, okay. So now if you see this example number 1, okay, after 1 we have 3, okay, strictly increasing. After 3 we have 5, strictly increasing, okay, that's it. After 5 we have 4 now, right? So it is going to decrease. So let's say this is 0, this is p now, okay. Then now after 5 4 is decreasing, right? Then 2 is also decreasing, okay, until here, right? So here let's say this is q, all right, okay. Now here after this again 2, and after 2 we have 6, okay. So again increasing, so let's say this is n minus 1. So at least 4 elements should be there in nums, okay. So this example we have more than 4, okay, so we are good. So here if I just give the indexing here, 0, 1, 2, 3, 4, okay, 0, 1, 2, 3, 4, and 5, okay. So here if you pick p as 2, okay, and q as 4, all right. So here nums 0 to 2, 1, 3, 5 strictly increasing, okay. So 1 is smaller than 3, 3 is smaller than 5, okay, strictly increasing, okay. If I have elements like this 1, 3, 3, then it is not strictly increasing, okay. It is not strictly increasing because these two are same, right? For strictly increasing, 1 should be less than 3 and next element should be less than previous element, okay, like this. Then here from 2 to 4 we have to start, okay. So here 5, 4, 2, okay, is strictly decreasing, all right, okay. And nums 4 to 5, 2 to 6, okay, is strictly increasing, right? Clear with the explanation, right? So this is what you need to do, okay. So what you need to do first, calculate the size of this nums array, okay. If the size is less than 4, okay, then simply return false, okay. So here if n is less than 4, return false, okay. A trionic array must have at least 4 elements, okay, and we proved that here, okay. All right, once this is done, then after that create one array I, okay, create one index I, okay, and here just iterate over all the elements, okay. So here if you start from here, okay, so we are checking first this condition, okay, n is less than 4, okay, only then we are start moving, right? So I can simply start from index plus 1, okay. So here I'm going to start from here. So previous element, okay, previous element is I minus 1, so this I, okay, value at this position is greater than this, right? True. Then I'm moving here, value at this index is greater than previous, okay, done. Then after that I move here, So I'm going to see that no. Uh, okay, now values are going to be decreased. Okay, so I will stop here. Okay, so until here all the values are increasing. Okay, so what I'm going to do, I'm going to create one index I is index equal to 0. Then I'm going to find strictly increasing sequence. Okay, index plus 1 less than n, right? And nums of index is less than nums of index plus 1. Okay, clear? Okay, you can write it like this, or you can also write opposite way. Okay, so if nums of index value is greater than nums of index plus 1, all right, then you are just going to increment the index. Okay, index plus plus. All right, this is done. Okay, so here once this is done, so you can just simply increasing the index. Okay, so here if I just take the example here, 135,246. Okay, so let me prove it here also. 135, 4, 2 and 6. Okay, so now here index you are taking 0, right? And here you are doing index plus 1. Okay, index plus 1, right? And here index plus 1 is less than n. Okay, so you are just validating. Right now your I is 0 here. Okay, so index plus 1 is less than n, right? So yes, I plus 1, if I do, I just going to reach here. Okay, that is less than n. And nums of index, okay, value at this index is smaller than this. Okay, so yes, 1 is less than 3. Okay, so in that case your I is moving further. Okay, your I reach here. Okay, this is done. Then here again you are going to check index plus 1. So index plus 1 means this. Okay, this is less than the total length, right? And nums of index, okay, this value. Okay, so 3 is smaller than this value 5. Okay, so again your I is going to move here. Done. Okay, then again you are going to check I is less than this n. Total n size is nothing but 1 2 3 4 5 6. Okay, n is equal to 6 here, right? So yes, it is less than 6. Okay, this, so this is valid. Okay, so I'm checking this here. Okay, because I want this value also, right? If this value itself is not there, then I have to return false. Okay, then I will not be able to execute. Okay, I will get error. So I'm checking this condition here itself. Okay, right? Because I can't fetch this if index plus 1 itself is going out of loop, right? Okay, so now here 4 5 5 is less than 4. No, right? 5 is not less than 4. Okay, clear? So I'm stopping here. Okay, I'm stopping here, right? So my I is here. So now if my I is 0, okay, if I'm at starting position only, I need 0 to p, right? If 0 to p, this is what I need, right? 0 to p, it should be increasing. Okay, and p is greater than 0. Okay, so if my index is still 0, that simply means after 1 I didn't find any element. Okay, let's say after 1 we have 1 only. Okay, I'm here only, right? So then 0 to p, there is no sequence. Okay, so if index is equal to 0, then I'm going to return false. Okay, no initial increasing part. All right, this is done. And after that I'm going to say that this is my first peak. Okay, first peak here, this is done. Okay, first peak is equal to index. Now I have to find the strictly decreasing. Okay, so here again index plus 1, same condition, index plus 1 less than n. And now nums of index is greater than nums of index plus 1. Okay, so here 5 is greater than 4. Yes, so your I is moving here. Okay, strictly decreasing. Okay, now 4 is less than 2 here. Okay, 4 is greater than 2. All right, so yes, true. So your I is going to move here. Okay, now after that here you have to stop, right? After that 2 is greater than 6, no, right? Okay, so you have to stop here. So this is done. Okay, so here you are just going to check here, this is decreasing sequence, right? So you are just going to check here if your index is still equal to first peak. Okay, if first peak and here index again stop here only. Okay, we didn't move anything further because we need p to q, right? So definitely there will be some elements in between because p is less than q, right? Okay, so if my index is still at first peak, then again return false. Okay, so this is what I'm doing here. If index is to first peak, return false. Okay, no decreasing part. And otherwise just take this as value. Okay, value, let's say this is value. Okay, all right, and this is first pick, this is value. Okay, now again you have to start. So while index is plus 1, okay, same like this. Okay, because we need to find increasing sequence. Okay, index plus 1. Okay, once we cover this, okay, so after this we all need, what we need increasing elements only, right? So we have to just check this. Okay, increasing sequence. Okay, and in the end 0 p q, and in the end I have to cover all the elements. Okay, with this strictly increasing, right? So here I'm going to do this, going to run this, okay, and here in the end I'm just going to make sure, ensure it ends at the last element, okay. So index is equal to n minus 1, right? And definitely this value, okay, the index of this value, okay, it should be greater than the first peak, right? This should be greater than the first peak, right? Okay, and value, it's value, okay, this value it should be less than n minus 1, okay. I don't want y value to be end at the last position, okay, because after q I need n minus 1, okay. If both are same, then I don't have any elements, okay. So q is less than n minus 1, right? So that is why I'm writing like this, okay. So this is the code for this, okay. So I hope that you guys are clear with the question number 1 of weekly contest 461. If you guys still have any doubts, then please feel free to write in comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye.